Good morning, everybody. It's a pleasure to be here. I'm responsible for electrification, for essentially bringing zero emissions technologies to aviation. And it's a pleasure to be in Oslo, in Norway, where I think you guys have done an incredible job in already pushing for the electrification in the ground transportation sector. And now I'm going to give you a taste for what we're doing to bring that same momentum into the aviation sector. We're interested in this not just because morally it's the right thing to do, which of course it is, but strategically this is, and we are convinced it is, the direction for us to go. If you look at how renewable energy is growing, whether it's wind, which has ×2 growth over the last 5 years, or photovoltaic, which is ×6 in the last 5 years, there is today, and it will continue, an exponential growth in renewable energy. As a company, we want to take advantage of that. We want to benefit from that growth in energy. We will see a decline in other energy sources over the decades to come, and we want to be on the zero emissions pathway. At Airbus, we already flew in 2015 the EFAN across the English Channel. It was our first scale demonstrator. It's a fully electric aircraft, 60 kilowatts in terms of total power, 30 kilowatts in each electric motor. It taught us, we learned a lot about what are the opportunities associated with electrification, but also some of the challenges. We learned about electromagnetic interference and how when you put high power beside avionics, this needs to be well filtered and designed and integrated into the vehicle differently than on conventional aircraft. We also learned a lot about the thermal challenges associated with higher power electrical systems. On the opportunity side, though, we could see a huge benefit that electrification brings to aviation. Less parts count means higher reliability and lower cost. The simpler system being something which really we believe airlines can take advantage of in the future. We also started to see that the flexibility provided by electric propulsion systems allows us to really rethink aircraft design. And so in 2018, we had the first flight of the Vahana vertical takeoff and landing demonstrator. That aircraft has been flying since then and has accumulated more than 100 flights now. It has a tilt wing configuration, so in cruise the wings tilt into a horizontal position, allowing the aircraft to be very efficient in forward flight. And we've learned a huge amount again based on that demonstrator, which gives us confidence for the next steps. On the 3rd of May this year, we flew the City Airbus demonstrator. So this is a 4-seat, fully electric, zero emissions, vertical takeoff and landing demonstrator. It had its first flight near Munich in Germany, and the flight test program is currently underway. It's a 2.2-ton vehicle, fully battery electric, really pushing the limits of the technology and helping us develop further the technology for even bigger applications. And what does that mean? So that means that we're focused on bringing the technology that you've seen on the vertical takeoff and landing applications into commercial aviation. So we've launched the EFAN X demonstrator. It's the demonstrator you see in the photo here today. It's got the green engine as a 2 megawatt fully electric motor, replacing the traditional gas turbine. And inside the aircraft, there are batteries, and there's a gas turbine connected to an electric generator, so we can test fully electric flight and hybrid electric flight on the same demonstrator platform. That's 2 megawatts. 2 megawatts compared to the original EFAN, which was 60 kilowatts. And we have just opened a facility in Munich, in Germany, which allows us to test up to 20 megawatt propulsion systems, 20 megawatt hybrid electric propulsion systems. 20 megawatts is roughly the equivalent of an A320 engine. So it gives you an idea of how serious we are about delivering this technology into commercial aviation, with the commitment behind this kind of facility requiring significant investment to make it happen. And because of the confidence level that we've achieved on the technology side, because of the flight test demonstration we've done on the various vehicles and what we are preparing for EFAN X, we decided that it's time to get an airline customer perspective on some of our activities. So in May this year, we signed a memorandum of understanding with SAS, and through that collaboration, we can start to understand what are the challenges, but also the opportunities around hybrid electric aircraft in real-world operations. So when, for example, we have the first fully electric aircraft coming into service, we know that those aircraft will have a shorter range than their, let's say, gas turbine or kerosene-powered cousins. What does that mean for an airline? How does it impact the fleet network, the fleet operations of the airline? What about recharge time? How does that impact on the aircraft utilization and the way that airports need to organize themselves or airlines need to organize themselves during the turnaround time of the aircraft? And that already those discussions have started. We've had several working sessions with the SAS team, and we can see that this is hugely beneficial in really helping us design what will be the future of electric flight. Thank you for your time. I hope this convinces you that this is possible. I think for a long time, aviation has been seen as a difficult area to decarbonize. It is a difficult area to decarbonize, but it is technically possible, and we're putting everything behind this topic to make it happen.
Thank you, Glenn. Give him a warm applause. We're so glad to hear that it's possible. And as we are flying a lot in Norway, of course we wonder when and what can the politicians and the government in Norway do to get these electric airplanes here? Do you have any advices?
This is an incredibly ambitious endeavor. It's extremely exciting, but extremely ambitious. It has a lot of risk attached to it. It requires a lot of changes in terms of infrastructure. It requires investment in terms of product development and technology maturation. I think we are going to need, not just at the level of Norway, but even more globally, public-private partnerships, and if Norway is interested in pushing that, public-private partnerships in the Norwegian ecosystem, which push for this technology to come to fruition in the next few years.
Thank you.
Thank you, everybody.